This video is for those students who are preparing for OJEE lateral entry, basically for the students of diploma students. As you may know that in this year the syllabus has been a little changed, so there will be a new subject that is of basic electronics. So in this video we will discuss the most probable questions for the newly added subject that is basic electronics. Here in this video, I will discuss the questions and answers as well as I will give you the subject knowledge so that will help in your exam. So without any delay, let's get started. Before starting, these questions are not made by me. These are collected questions. So, coming to the first question, question number 1, the separation between valence band and conduction band is known as. Before answering this question, let me give you some brief idea about matters and their energy band with proper diagram. In solids, there are two types of energy band. They are valence band and the conduction band. And the conduction band. And in between them there is valence band and there is conduction band. In between this there is a energy band, that is gap, energy gap. This is the energy gap. That is the forbidden energy gap. So what is a valence band? The range of energies possessed by valence electrons is known as valence band. And the conduction band is nothing but the region where the free electrons are present, that is called conduction band. As solids are divided into conductors, semiconductors and insulators. So basically we have three types of energy band. Now let us see for the energy band diagram for the insulator. For insulator, suppose there is a valence band. Here this is the red is the valence band and this is the conduction band. So here this gap that is a forbidden energy gap between this conduction band and this valence band is big. Now let us see the energy band diagram for the conductors. For the conductor we have the valence band and suppose this is the valence band and we have the conduction band. You can see that these are overlapping to each other. That means in conductor the conduction band and the valence band are overlapping to each other. There is no forbidden energy gap. Now let us see the energy band diagram for the insulator. For the insulator, the energy gap between the conduction band and the valence band is very less. Now from the discussion you can clearly answer the question number 1. That is the separation between valence band and conduction band is known as forbidden energy gap. Now coming to the next question. Question number 2. In which material, valence band and conduction band are overlap to each other. From the previous discussion, you can clearly answer this question as well. That is, the conduction band and the valence band are overlapping in conductor. Coming to the question number 3, a semiconductor has dash temperature coefficient of resistance. For the semiconductor, the temperature coefficient of resistance is negative. For insulator and semiconductor, the temperature coefficient is negative. But for the conductor, this temperature coefficient is positive. Coming to the question number 4, that is, a semiconductor is formed by dash bond, that is covalent bond. Next question, a crystal diode is used as rectifier. A rectifier is a device which converts AC to DC. That is the rectifier. We have different types of rectifier: half wave rectifier, full wave rectifier, and in the full wave rectifier we have center tap as well as bridge type rectifier. So in the next question, question number 6, a crystal diode is a dash divides in the sense of linear or non-linear. A crystal diode is non-linear. The next question, reverse saturation current of diode is due to the minority charge carrier. We have two types of charge carrier. One is minority charge carrier and the other one is the majority charge carrier. In the next question, 8, number of PN junctions in a Zener diode has 2 numbers of PN junctions are in there. In the next question, Zener diode is used as voltage regulator. Now, let me give you the symbols for a diode as well as for Zener diode. For diode, the symbol is like this, and for Zener diode, this is similar to this but having some modification like this. This is Zener diode. Now coming to the next question, Zener diode is always connected in reverse bias, but general purpose diodes are used as forward bias. But Zener diode used as or connected as reverse bias. The next question, question number 11. When more than one components are fabricated in a single chip is known as IC, that is integrated circuit. IC means integrated circuits. In the integrated circuits, components like resistors, capacitors and transistors are fabricated in a single chip, that is called IC. But here you have to remember one thing, inductors that is L, these are not used in IC. Inductors are not used in IC. Coming to the next question, number of diodes required in bridge type rectifiers are 4 number of diodes are used. For a half wave rectifier, 1 number of diodes are used. For a center tap full wave, 2 number of diodes are used. For a bridge type, 4 number of diodes are used. In the next question, the maximum efficiency of a half wave rectifier is 40.6% and for a full wave it is of 81.2%. In the next question, what is the full form of BJT? Bipolar junction transistor. We also have FET, that is field effect transistor. FET is field effect transistor. The next question, number of terminals in transistor. In transistor, we have three types of terminals. They are base, emitter and collector. A transistor has dash number of PN junctions. In transistor, we have two number of PN junctions. Let's see the symbol of the transistor. Transistor have two types. One is PNP, one is PNP, and the other one is NPN. We have two types of transistor, PNP and NPN. Now let us see the symbolical difference between these two. Now let us see the transistor symbols. In transistor we have three terminal. We have base, this is base, this is collector and this is emitter. For a NPN transistor, the arrow in the emitter is outside. This is outside. This is NPN transistor. When this arrow is inside, we call it as PNP transistor. Now coming to the next question, the current relation in transistor are I, that is emitter current equal to base current plus the collector current, that is IE equal to IB plus IC. Now let us see the current amplification factors. They are, or gains, they are alpha, beta and gamma. Alpha equal to IC divided by IE. That is the current ratio between collector current and emitter current. Similarly, beta equal to, that is the ratio between IC, that is collector current, to IB, that is base current. Beta is the ratio between collector current to base current. Similarly, gamma equal to the ratio between IE and IB, that is emitter current to the ratio of base current. So here I have explained you alpha, beta and gamma. In the next question, for the faithful amplification of transistor refers to, for a faithful amplification, we need to increase the magnitude of the signal with change in shape. Sorry, without change in shape. Without change in shape. Without change in shape. Here this is incorrect. Without change. So in the next question, which electron emission is known as cold cathode emissions? We have field emission. Field emission is known as cold cathode emission. We have four types of emission. They are thermionic emission. In the thermionic emission, we are giving a thermal temperature so to release the electron. This is called thermionic emission. In the secondly, we have secondary emission. In this method, a high velocity beam of electrons strikes the metal surface and causes the electrons of the metal to be knocked out from the surface. Is known as secondary emission. Similarly, we have photoelectric emission. In this method, the energy of the light falling upon the metal, this is a metal, the energy from a light is falling, energy from the light or sun is falling on a metal and releasing electrons is known as photoelectric emission. Lastly, we have field emission. In the method of field emission, a strong electric field is applied to the metal surface which pulls the electrons, is known as field emission. Coming to our question, which electrons emission is known as cold cathode emission? Field emission is also known as cold cathode emission. Next question, a multimeter can measure. A multimeter, you can see we have analog as well as digital multimeters. The multimeters are measures as voltage, current and resistance. The voltage and current for both AC as well as DC. For the small type of digital multimeter, we can't measure the AC current, but a large or higher rating digital multimeter, we can measure the AC current also. In the next question, which converts a physical quantity into electrical signal? Transducer is a device is called which converts the physical quantity into electrical signal. Physical quantity into electrical signal. The device is known as transducer. Now, let me explain you the communication process. As we are using telephone communication and normally we talk to each other, that is also a communication. For a communication, let us discuss it with a simple block diagram. For a communication, we have two things. One is message source and the other one is the destination. Suppose two people are talking to each other in phone. So one person who tries to calling to his friends or anyone, so he himself is the message or source, and the other person he tries to call is the destination or the receiver. Here the message is Here the message signal goes to transducer. In transducer, it converts the message signal or the physical signal into electrical signal. And the electrical signal is transmitted through different medium or different channel. In the channel, we also produce noise. After transmitting, it is received by the receiver. After receiving, it will decode the signal and it will understand the message, what the messenger was saying. For this process, we have modulation as well as demodulation. So, modulation in communication system, transmitter modifies this message signal into some form of suitable to transmit over a channel. That is called modulation. We have three types of modulation. They are AM, FM and PM. AM, that is amplitude modulation, FM, that is frequency modulation, and PM, that is phase modulation. In amplitude modulation, amplitude is changes. That is called amplitude modulation. In frequency modulation, we change the frequency. That is called frequency modulation. In phase modulation, we change the phase. That is phase modulation. Now let us see, we have a signal and we have a carrier. Carrier signal is used to superimpose over the signal, so to get some modulation signal such as PM, FM or AM. AM is amplitude modulation, PM is frequency modulation and PM is phase modulation and FM is frequency modulation. Now let us see what is demodulation. The process of recovering the audio signal from the modulated wave is known as demodulation. For discussion of questions among yourself, I will put a Telegram link below my description. You can join among yourself and discuss yourself. Hope you like this video. Please share, like and subscribe to my channel. If you have any doubts, feel free to ask in the comment section. Thank you.